simple inequalities. So the question that comes up is, how is solving x plus 3 is less than 4 similar to solving the equation x plus 3 equals 4? Well, it turns out that it's the same thing. You solve it the same way, but some of the problems that we may solve, some of the inequalities that we may solve, could have some minor differences. So first of all, let me just say that solving any inequality where the equal sign has been replaced with an arrow is done exactly the same way that it is when you solve an equation, except for the exception I'm about ready to show you. And that takes on this form. So take a look at this. If we have negative 6 is less than 8, we can see that that's readily true. But what would happen if I multiplied both sides of that inequality by negative 2? So I'm just going to multiply by a negative number. And if I do that, I'm going to negative 2 times negative 6 is 12. And negative 2 times 8 is now negative 16. So when I multiplied by a negative number like that, it turned out it changed the signs of the inequalities, and even though the numbers changed, it is now true that the one on the left is bigger than the one on the right. So if I did the same thing, only I did division, let's try division. Negative 6 less than 8. Let's divide it by negative 2, just for the fun of it. We're just dividing by a negative number to see what happens to an inequality. And this is the only exception that we're trying to point out. Negative 6 divided by negative 2 would be 3, and 8 divided by negative 2 is negative 4. So it would make sense that the inequality arrow would flip the other way and point to the right instead of pointing to the left like it was originally. So what we've tried to demonstrate is that by multiplying both sides of an inequality with a negative number, or dividing both sides of an inequality with a negative number, forces the arrow to switch directions. And that's the exception to the rule that we'll see. So let's go ahead and get into that. When you multiply or divide by a negative number, you have to flip the inequality sign to keep the inequality true. So that's how we summarize that little rule that we just demonstrated. All right, so now we're going to get right into solving some two-step inequalities. The one-steppers are pretty easy, so let's just get right into solving some two-steppers. So this is the Great Wall of China, and we said that we solve these the same way we do an equation. So we're going to add that 4 to both sides. Sorry, that's not a very good 4. So add 4 to both sides, and I get 5x is greater than or equal to 15. Then I divide by 5, and my final inequality is x is greater than or equal to 3. You see, I just multiply, add, subtract, multiply, divide the same numbers like I would if this was an equation. And then down here, I can decide at this point where 3 is going to be on my number line. And in this case, it's going to be a closed circle because it's greater than or equal to. And all the x values that are greater than or equal to 3 would be off to the right like that. Okay. How about this one? Let's get our Great Wall of China. This one says all of this on the left is less than 9. So we're going to minus 9 from both sides. And we will end up with y divided by negative 6 is less than 9 minus 7 is 2. Now this is where we're going to have to multiply by a negative number. So we multiply by negative 6. And we just got through learning in that rule that whenever you multiply or divide an inequality by a negative number, you have to switch the arrow. So we're going to switch it right up front. Those 6's cancel, and 2 times negative 6 is negative 12. So it looks like that. So we're going to decide over here that negative 12 is over here because it's probably off over on the left side somewhere. And this says all the numbers greater than that. So we're going to have just an open circle at negative 12 with an arrow pointing to the right, just like that. All right, how about on this problem? We've kind of rearranged it just a little bit. So we're actually going to minus the 8 first because it doesn't have a variable on it. And it's just being added or subtracted to both sides of the inequality. So that's going to leave us with 9c greater than or equal to negative 28 minus 8 more would be negative 36. Now in this case we have to divide to solve, but the number we're dividing by is a positive number. And if it's a positive number, the inequality sign will not change directions. It's only if you're dividing or multiplying by a negative number. Now it doesn't matter if this number on the other side is negative, that doesn't affect the arrow. So negative 36 divided by 9 is just negative 4. So let's just call this negative 4 down here. We're going to color that in very carefully because it's greater than or equal to, and all the numbers greater than negative 4 are off to the right of negative 4. Okay, we got a couple more. Let's take a look at this one. This one looks like it's got a lot of negativity in it. Are we going to have to switch the arrow? Well, we'll find out. Subtract 5 from both sides. So negative 10 minus 5 is negative 15. And all of that is greater than negative 5y. Then we're going to divide both sides by negative 5. Negative 15 divided by negative 5 is a positive 3. And we said a few moments ago that if you have to divide by a negative number to solve an inequality, you flip it around. So the inequality symbol goes the other direction. However, as we look at this, what this is saying is that 3 is less than y. Or all the numbers, the unknowns, are bigger than 3. So if this is 3 right here, where are the numbers that are bigger than 3? They're actually over here. So we got an open circle at 3 and all the numbers bigger than negative 3. Even though we had to switch the direction of the arrow, this inequality was already written backwards, which kind of added another degree of complication to it. But we figured it out. Okay, so here's a couple. Write the following as inequalities. So the difference of c and 5, so the difference means subtract. So c minus 5 is at most, which is what we learned earlier, that is less than or equal to negative 17. Okay, a number y divided by 4, so a number y divided by 4 is less than or equal to 19. Now, I didn't say we had to solve it in this case, but in some cases you may have to write an inequality, solve it, and even graph it. So be prepared for whatever comes along. So our assignment this time is number 32, solving simple inequalities on Alex. So good luck.